This conference will now be recorded.
So how can I make a full screen? Check Durga, there must be some options with you for that purpose.
I
Okay.
see all the times, half of the screen. So it is toggle full screen, right? The 3 dots and toggle full screen, right?
Yeah, just try that one.
Yeah, I did that, but above to this screen, I see the attendee names and all. So if we can remove that, I think the screen will be much more bigger in size.
I cannot do one thing. Next time onwards, because I think I remember that you reported this issue first day also.
Yeah, the small screen and small letters, it's for
I don't
me
know.
the small letters.
Do one thing. Download this. Go to this one. Go to meeting desktop app, and that should probably solve that issues. Because maybe in the browser or something, some settings are not as appropriate.
Okay,
Other
then
people can
just
see it, right? Correctly. Other people can see that, right?
yeah, I'll try quickly and come back.
Yeah.
Maybe.
Yeah.
Okay, guys. Let's
For
focus.
others, everything is fine, Akhilesh?
Yeah, I installed that application, sir. It looks fine.
Okay. I'll do that then tomorrow. Yeah, you can continue, Rajesh.
Yeah. Okay, guys. So the first thing is, what is pod? This is the most important question which I was holding it. Now, I'm finding always, I'm teaching Kubernetes from last 5-6 years actually, and I always find it difficult to explain this one. What is pod? At initial level. Once you experience the pod, then everything is okay. But those who have no idea about the pod, how can I explain it? So I put a little bit in a context actually. Okay. So let's put it in the context. So for example, you know VMware, correct? All of you, VirtualBox, VMware, correct?
Yeah.
So VMware manages what? VMware manages what? Tell me. What they manages? VMs, correct now? Hypervisor manages the VMs, vSphere manages the VM, VirtualBox manages the VM, correct now? All of you? Now, Docker manages what? Tell me.
Containers.
Container. Wonderful.
Containers.
So guys, here, same way, Kubernetes have no idea about the container actually. Yes, Kubernetes has no idea about the container because container is managed by Docker, no? So what manage Kubernetes? What they do that? How they deploy their application? So see, in a VMware you deploy application in the VM. Docker you deploy the application in a container. So in a Kubernetes, what happens? Whenever you deploy application in a pod, and that's the reason you see that here. These all are applications, and it got deployed in pod. These all are pod actually. So yes, all these applications which is getting deployed in the Kubernetes pod. Kubernetes don't understand VMs, Kubernetes don't understand containers, Kubernetes only understand pod. So when you are on a Kubernetes, let's talk only about the pod. So this is the first line. Are you comfortable so far?
Yeah, right.
Yes.
Okay. So guys, second line. So VMs contain what? Operating system. Agree with me? Agree with me?
Yeah.
Container contain what? So root file system. I hope you remember the root file system. I hope so.
Yeah, we remember.
Root file system, user file
Yeah.
systems.
Root plus. So starting with root, right?
Yes.
Correct.
Yes.
Here you have a boot also. So Kubernetes contains what? You know, the funniest thing is Kubernetes contains containers. Containers, I said each can contain one container also, multiple container. Yes. So what is a pod? So pod is wrapping around the container. Simple. So in a pod, you have one container and two containers. Okay, in a pod, you have a one container, two containers. So you can say pod is like a, you can say something like a pod, like a label, something like that. So in a pod, you will have a container, one container or multiple container. So guys, here in the world of VMware, US get IP address. So here in the world of container, you know, container get IP address, which I showed you yesterday. I mean last session. In Kubernetes also, pod get IP address. So that means if you want to access, you have to access the pod, not a container. So inside a pod, you will have a container which you basically indirectly access it. Are you able to get comfortable with that? Kubernetes pod has container can be accessed through the pod IP address, all this thing. Are you understanding?
Yes.
Yes. And I'll tell you guys, in the container, now let's talk about the container lifecycle. Okay, container lifecycle, which you know that very well. Container lifecycle, we create a container. Yesterday we did that. We create a container. You can start the container, you can stop the container, you can kill the container, you can pause the container. All these things you can do that with the container. But pod, you cannot create a pod. See the confusion here. Yes, pod cannot be created. Pod cannot be started. Pod cannot be stopped. Pod cannot be what do you say? Pod cannot be restarted. All these things. You cannot pause the container, a pod. Okay, so pod container is a, I will say, physical entity which you can experience. Physical entity, you can say entity. But here pod is basically a virtual entity. Virtual entity. I'll put it in a more context way. So can you touch the sky? Tell me, can you touch the land? Can you touch the land?
Yes.
I can touch you, you can touch me, I can touch a laptop, I can touch keyboard, I can touch a bus, I can touch anything. So these are the physical entity. But can you touch a sky? No, I cannot touch. But still, we all are inside a sky. Correct now?
Yes.
Okay, so here pod is a logical entity. If someone will say, hey Rajesh, I want to go inside a pod, how can you go inside a sky? But if you say, hey Rajesh, I want to go inside the land, yeah, you can go. So container you can see of the pod, but pod you cannot see. Pod is not generating any waste. For example, you cannot see the logs of the pod. If you can see the logs of container, but you cannot see the logs of the pod. You can access the container of the pod, but you cannot access pod. See that? So what is a pod? Pod is a logical entity to contain, to wrap the containers around it, and then Kubernetes manage, Kubernetes deploy application in a form of pod. Are you understanding, all of you?
Yes, Rajesh.
So guys, if you ask me, Rajesh, give me the pod which got destroyed yesterday, I'll say I cannot give it to you, because same pod you will never get it. Kubernetes will never give you same pod. Then which pod you will get? Similar pod. Similar, Kubernetes will create a similar pod, but not a same pod. There is a difference, same versus similar. You have to understand. So the pod cannot be redeployed again. It's there or it's not there. Simple. So the state of the life cycle of the pod is, it will be in the pending. Pod can be instantiated. Container can be created. I showed you the command container docker create and container ID. I mean image. But pod you cannot do that. Create. You have to instantiate. Now, what is the difference between create and instantiate? Anyone would like to tell me? Instantiation versus creation. Anyone?
Creating can be visualized where like we can see the location of it, where it is and all.
So initiation means, do you know that the act of Brahma, right? Okay. So he is instantiating the each object, each class. Instantiation means he's creating a property of each class. But who's creating it? We human are, or other natural things is creating the object. For example, human is a class, but that's Brahma create the human? No, he's created a skeleton, I mean class, 2 hand, two leg, 2 eyes and all. But who produced that human? We human only produce the human, right? Creating, right? So it's like this. Pod is a logical entity. So pod can be instantiated, whereas container can be created. So the pod, the something which you cannot create, how can you stop and start? You cannot do that. So pod cannot be created, pod can be instantiated. So it is in pending state and running state. That's all. These are the state: pending, running, succeeded, failed. Okay, succeeded, failed, something like this. Are you understanding? There's no create, start, stop, restart, all these things, blah 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 for the pod. Yeah, any questions?
So how do we get to know, like, yeah, there is a pod there and the containers are inside that pod? How do we
For
get to
that,
know that?
I just got to know here. I just got to know how many pods are there. These many pods are there. How many this one, what do you say, in a container inside the pod. So there's command for everything. Describe pod, which pod, core DNS. See how many containers are there. In these 2 containers are there, no? So you see here. There's a spelling mistake. See, this is the complete detail of the pod. How many containers are there? Container ID. This is the 1 container. Go down. Second container, where is that? There's another container. Got it?
Yeah.
So yes. So
So
some of, yeah, tell me.
Rajesh, as you said, like Kubernetes never creates the same pods. So when it creates the similar pods, so might be the IP address gets changed, right?
100% correct observation. By the way, you can customize and you can inform Kubernetes, hey Kubernetes, don't change the keep this range and all stuff like that, but IP address will change for sure.
Yes. Okay.
So that's the reason I was telling to the Durga, don't stick to your application instance. It might come, it might go, you never know, but the only thing, concept you should understand. So you can correlate that, why I was saying don't get attached to the applications and all. What will happen once the application will get destroyed? What will happen? This is a regular thing which is happening in the production actually. So
Yeah.
when you log into the Facebook, you don't log into the single machines through that. There is a session, different server, login server, your whatever the state of application is in different location, and static is different locations. So like that.
Yeah.
Okay, so I don't know how many of you have understood, but slowly we'll get it. But let me conclude this pod. So guys, pod is a unit of deployment in Kubernetes. That means in Kubernetes, when you deploy pod, you deploy the pod. Pod is containing containers. Pod get an IP address. Pod get a volume. Pod get a storage. Everything you get it allocated to the pod. So any number of containers which is inside a pod, which is of the pod, will share the all resources assigned to the pod. Okay, like IP address also. Pod cannot be created, it can be instantiated, and the life cycle of the pod is pending, running, succeeded, and failed. Pod can be instantiated by kubelet. That is important. Pod can be instantiated by kubelet. Look at this image here. Follow my cursor. Kubelet, pod, container. So pod is kubelet, and kubelet you have here also, master also, worker also, everywhere you have kubelet. So this is the pod at a high level. Let's move on to the next things, and how do we work with it? So some of the commands I would like to know. So I have given you some of the commands here in the notes also. You're going to get comfortable with it. Okay. And after that, I'm going to give you some more commands for it. So some of the command is, let's say I don't know any commands. So what should I do? Kubectl. Oh, I got so many commands here. So many commands I got to know. Whether you understand or not understand, please read at least once this command. There's no harm in it. No, you're not understanding, no problem. But at least you are getting familiar with this keyword, right? That is more important. Okay, so try to understand this. After that, you want to know how many resources you have, which you want to learn. So API resources. Again, try to get comfortable with all these things, resources. Spelling mistake actually here. So these are the resources you have to learn throughout your 57, I think 73, I think, because Calico is got destroyed, right? Grab 72, total 72 resources you have here. Okay, so total 72 resources you have to, these 72 resources you have to learn, out of which 15-20s are belongs to Calico, the remaining you can learn. So here, let me minimize this one a little bit less. Just get comfortable with it. So I'll teach you anyways, many of these. Here. So these are the things you have to start with, V1, and slowly you have to get into that. So your job in Kubernetes is, learning these resources, how to use it. I'll teach you. So here, name, short name, just get comfortable. API version, namespace, true and false, kind of. So here you have API versions also, this command. So these are the version which is supported by the API server. Okay, so most of these are V1, you will get V2 and all stuff like that. So yeah, now what is the kubectl version which you are using? What is the server version? This is the command. See here, client version 1.236, 236 server version. Okay, so all this thing which is important. Okay, so overall these are the commands which we need to run and get comfortable with the server. All of you understanding that?
Yeah, Rajesh, could you please go? Rajesh, could you please go to once that architecture diagram, that cube? Yeah. No, yeah, that one. Yes. No, the below one. The below one. Yeah. Here you said about kubelet, right? So what is this kubelet?
Agent. Kubelet is an agent which has to run in each worker of the cluster, including master and worker.
Okay. Kubelet.
If this guy is not running, your cluster is not stable. Simple. If that guy is not running in the worker, that worker is not a part of the cluster.
Okay.
Okay, so now this is the one. Now I'll teach you few component. Before that, I'll give you some time to get comfortable with it. So whatever the command I run, you have to run the same command, observe the output and all stuff like that. So few component which I'm going to teach you is namespace. I'm going to teach you how to create a pod, and then I'm going to teach you replication controller. This is the things. Tomorrow I'm going to teach you deployment and services, very important one. So these 5 resources I'm going to teach you in the cluster in this session, and these are the 5 resources you want to understand how. So let me put it in this way. Pod means, you know what, EC2 instance. I'm just trying to correlate. Okay, replication controller means what, ASG. Have you worked with this auto scaling group? Deployment means, yeah, so multiple EC2 instance and plus ASG together. Okay, plus ASG together. Services means load balancer. So these are the most important one, but there are more than 57 API resources which is given. We'll have to learn those also. So like that. Okay, so now I'm going to give you the IP address and keys. Let me publish it. So go to the GitHub. IP address and keys nodes. This is the repository I created for you guys only. Softility. So here you have Kubernetes1.txt. Okay, and this nodes I'm pushing up, and here it is. Now where is your ppk file which you can use with the putty? So upload ppk file, and where is that ppk file? Don't copy the key, always download. I repeat, don't copy the key, always download. Many people just download it and then use the wrong key, corrupted key. PM, those who wants, I am uploading the PM also. Okay, those who are not comfortable with the PM and all stuff like that, I can set the password also for those people. So etc sshd sshd configurations. Let me set the password also for people who are not comfortable with the key concept. So where is the password? P.
Down password.
Yeah.
Yes, there. Password authentication, yes or no?
Yeah. Actually, your view is good. Actually, I was not able to see that actually, that keyword. Not sure why. System CTL. Restart SSHD and then password Ubuntu, right? Ubuntu Raju123. Raju123. So guys, this is the password for cluster master, and username is Ubuntu, and password is Raju123. So this one is off. I'm putting the chat window. Did you confirm if you received the chat window? All of you?
Yes, Rajesh.
Yeah. So guys, go ahead. I updated this nodes, and now Kubernetes. I'll update this one more time because I changed the password. So everything you have in the nodes, all the commands, and that URL I'm sharing with you about this. So I'm putting the chat window. So I'll give you 15 to 20 minutes before me talking about the other resources. As the
This
troubleshooting.
conference will now be recorded.
Okay, so right now I'm not interested in a person to find out who has done it rather than fixing its issues. So here if I do kubectl get nodes, okay, right now has come. I think someone modified the code and again someone has modified the reverted back. Who's the great person? Anyone? He reverted the code again. Someone is doing actually. Without knowledge, he's doing it for sure. Okay. So at least mastered we got it. Okay. He might have modified the configuration file like this. Okay. So now master is there and worker is not there. Okay. So worker is not there. So for that, what I can do, I can reset the worker. And yes. Okay. And after that, some changes I have to do. And that is while resetting it. I'm just doing it just again. Hold on. So IP tables has to be clean. This is not required. It's not required here. So one more time I'm clearing this, setting this, yes. So IP table has to be clean. The command is not here. So that's okay. So after that, I'm going to run this command. The command which I stored last time, this one. Before that, you know what? I will little bit of clean up this etc config kubelet file and all. So where can I clean up? So this is the locations I'm having. Yep. So rm I did clean up. Okay. Now I'll do one thing. You know what? Kubelet, which is running as a process. ts-kubelet, and oh, it's not running. Wonderful. So systemctl restart kubelet. It will not run, but still I'm doing it because I want to check is there any problem with permissions. Okay, with that I'm just running this command. It should restore all this stuff. So if it's not doing, then we have to do the little bit of different troubleshooting, which I'll just ignore it because my objective is to learn some of the resources on Kubernetes rather than exploring the worker who has modified what, tracing it, correcting it and all. So let's wait for a few seconds. Master is up and running. Guys, without knowledge, okay, without a knowledge, don't do any changes, because what will happen now, it's just like a training boxes. But if you this kind of attitude if you do in the production boxes, it will bring disaster to your project. Okay, so have a knowledge.
Rajesh, did you give the worker node access as well?
Worker node access is also given in the same machine. It's the same server, and on top of that, the worker node can be deleted from the master also, workstation also.
No. I am asking, like, I was only logged into one server, that is master node, and then worker node user credentials you have not shared. See there?
It's the same one. Same keys will
Same
work.
one. Okay.
Yeah.
So I didn't logged in. I thought like.
Yeah. One more thing, to delete the worker, you don't need to get into the worker. You can do it from the master itself. That's what I'm saying. For example, if you want to delete that, you have to just delete the node. Okay, no, delete and node and the node name. That's all. So it will get deleted.
Which node will be get deleted?
Worker node.
Worker node.
Yes.
Okay.
Okay, so now this is happening right now. Let's happen, but I don't have a patience for waiting for that. What I'll do. So guys, here what I did, master, I made it workstation also, master also. Now what I will do, one more thing, because of this situation, I'll make a master as a worker also. You tell me why. Think simple way. Okay, so here you see in the worker, what are the components we have? Proxy we have. Do we have a proxy in the master? Yes. All the components we have in the master of worker? Yes. So I can make master as a worker behavior also. Now the question is how come? So let me find a command for it. So here, make Kubernetes master. Make master schedulable. Just so here, this is the command. Stack overflow. This command will make the master as a worker also. Okay. So some problems, new opportunity to learn, and this is a node. Here it is done. So guys, this command will make that my master deployable for worker. So let me see if it is fixed or not. No, and done. So now my master is also worker. So your cluster is ready anyways with the worker, but yeah, it will be deploying the pod in the master one. Okay, so let's get started, guys. So first thing, the question is, what is a namespace? Here, what is a namespace? Okay, so this is the first question. what you have in the namespace. So you need to understand this very carefully. So let me create a cluster image. So this is your cluster powered by 3 worker, maybe 300 worker also, but just for the demo. Now here, this is my one project. Okay, this is my one project, and this is another project in the red. So guys, when you deploy the pod in the Kubernetes, so this blue project deploy the pod, 3 pod, 1 pod, 2 pod, 3 pod. If you notice that this pod is running this worker, this pod is running this worker, this pod is running this worker. Now when you see that red project also deploy the, let's say, 3 pod, 1 pod, 2 pod, 3 pod, and this pod is running in this pod is running this pod is running this. Now you know, in the real time, cluster is being shared by multiple projects, multiple teams, and all stuff like that. Okay, so the pod, I mean, whole cluster is considered to be one. You cannot say, hey, project 1 will deploy only in the node 1, project B will deploy in the node 2. So vertical isolation is not there. Okay, so far so good, right? All of you understood this? So far so good, right?
This diagram I didn't understand, Rajesh.
This is a cluster
Okay.
powered by 3 worker.
Okay. Below are the workers.
Below are the worker. This is worker node, worker node, worker node.
Okay. And the above one is the master node.
No. You have to just take one task offline. What is a cluster? You have to understand. Cluster concept is there from last 20 years. So what is the concept of cluster? Cluster you have to understand. Okay, so cluster means
what was the top one? What was the top one?
This is the cluster. I am talking about cluster.
Okay, so that is the cluster, and this is the below are the worker nodes.
Okay, yeah, I'll put it in this way. Let's say you have a 5 worker node and 2 GB each worker node you have it. So what is the total capacity? 10 GB.
10.
Correct? Now?
10.
So the capacity of cluster is 10 GB. So if someone will ask you, hey, what is your data center capacity, cluster capacity? So it's a 10 GB. So no matter which is powered by 5 nodes or 10 GB. So here when I depict I'm depicting the cluster, which represent, it can be 3 nodes also, it can be 3000 nodes also, I don't care actually. The one which I care is, I care the cluster. Make sense? Yes. So if someone will ask me, Rajesh, what is your cluster size of Kubernetes? So I'll say, for time being, let's say 5 GB, 5 GB, 5 GB. So I'll say 15 GB RAM, 20 CPU, like that I talk about it. So here I'm saying, so that project 1, which is green, project 2, which is red, they deploy the pod. Okay, so they deploy the pod. So it's not like it will deploy only in this. This will deploy in the whole cluster actually. So it can deploy here, and this is running here, and this is running here. So basically, both the projects are sharing the same cluster, but worker can be anything. See, when you are talking about the cluster level, you forget the worker level. You are running the cluster. Make sense? Okay. Are you understanding or maybe confusing?
It's just like a profile for the cluster, right? Profile for dividing. It's just like a profile, multiple profiles for a Kubernetes cluster.
No. Cluster means not that.
Namespaces.
No, I'm not talking the namespaces actually. He's got a question in the, what is this background, this diagram? What is this diagram? That is a question. Okay. Cluster means combining multiple hardware logical unit into one multiple physical unit into the logical unit. So that is cluster actually. In a data center, we use a lot this keyword. So probably if you visualize this, see, this is the, look at this image of the clusters. See here, multiple hardware, multiple software is attached to the one cluster, one runtime environment. See, computer 1, computer 2, computer 3, all these things. Is a clustering actually we do that. Large data center when you set up a clusters. See that something like that. Are you understanding, Durga?
Yeah, I mean, multiple nodes can be set up in one place, right? So,
Yeah, multiple node can be set up for the one work for hosting application. That's called cluster. Means cluster is powered by multiple resources unit like CPU, RAM, hard disk, and so on.
yeah, and the pods which are running in the worker node, you mean to say those pods also running in the cluster?
No. Logically, we say our pod is running in a cluster, but reality, actually, this is running here or here or here. Who will decide? Kubernetes will decide in this case.
Okay.
See, there is a two definition. One is like a logical definition. One is a physical definition. So when you say you are running an application in a Kubernetes cluster, so this is combined space you are talking about. You have to understand the notions of it. Okay. So when we say, hey, I'm running the application in my cluster, that means you are not talking I'm running a cluster in the worker 1, worker 2, worker 3. No, you are running a cluster. This cluster represents all the worker of these machines. It may be running anywhere. I don't care about that one right now. Make sense?
Yeah, got it.
You have
And
to.
then what is the master? Then what is the master node?
Mastered is gone right now. In this whole world, this whole picture mastered is gone. What was the job of the mastered? Just to deploy the cluster pod, and then after that is gone. Make sense? In this image, I'm not talking about the master. I'm talking about
Still,
cluster.
I didn't get you, Rajesh. Like, what type of explanation would you like to give? Like, when master is the thing where you want to install and deploy everything, then why does the worker come into picture? When worker is there, it is correlated to master, right? Then, how is it working actually? I still really didn't get you. I feel like some part is missing, some
Okay.
connection is missing.
Okay. Anyone has got the explanation so far for this question? Because I'm little thinking how to explain. Anyone else would like to help me here? Those who
Yes.
understood?
Yes.
Yeah, tell me.
Should I explain the architecture point of
Yeah,
view?
please go ahead.
We have a master and a node concept where all together called as a cluster,
Wonderful.
and we from the laptop are able to log in into the master node and thereby installing the Kubernetes, and the components which are installed in the Kubernetes master are API resource, API server, scheduler, control manager, as well as etcd.
Mm-hmm.
Whereas in the node point of view, we are from Kubernetes point of view, we are appointing an agent which is known as kubelet, which
Wonderful.
talks to
Yes.
API server.
Yes.
And we have another component known as kubeproxy. Kubeproxy will be providing the.
Guys, can you mute yourself? Guys, can you mute? Let me mute everyone.
Am I audible?
Sorry, there was some disturbance from someone. Now you can continue. Yeah, you can unmute and continue. Yeah.
Kubeproxy is the one which is able to provide just a network connection for the pod.
Wonderful. Yes.
Whereas the etcd is just
Mm-hmm.
like the content which we, for suppose we have a state file in Terraform, where we will be issuing the Terraform the input values which we needed to make an infrastructure. Likewise, in Kubernetes, we make sure the container runs inside a pod. In Docker terminology, we refer containers, but in
Yeah.
Kubernetes, we call them as pods.
Pod. Yes.
Okay,
Okay.
the container which is running inside the pod will also take the Docker as its interaction, so
Huh.
that it will be pulling the image from the Docker repo and it will be
Yes.
running inside the container.
Correct. Yeah. But one
And
fundamental question actually I want you to answer. The question for this last person, he said, Rajesh, why do we have a master first place? That's the question. Can you answer?
To have a single point so that we cannot always go to the worker nodes, thereby to make a setup. We just will
Wonderful.
be taking a contact with the master so that master triggers the number of containers, number of pods that should be run, so that
Correct.
we cannot able to concentrate on the worker. If we
Wonderful.
provide the enough resources for the worker node, that is like CPU, RAM, etc., so that the
Hmm.
resources are divided in a quiet manner, so that
Hmm.
each pod is able to accommodate resources for its container.
Wonderful. One more question which he has said, what is the role of worker? Who's running application? Whether application is run by master or worker?
Application is run inside the worker node. No
Wonderful.
interaction with the application from our master side.
Yes.
We have a
Yeah.
load balancer which is
Just,
just
sorry, sorry to interrupt you. Right now, just keep it the load balancer idle,
okay.
this topic, because I don't want to confuse too many
Uh,
people.
just like
Okay.
in sir, you have skipped yesterday the concept of port forwarding, so it is getting some people difficult. So how the container is able to
Yeah.
manage an application? So
We'll,
if
we'll
you
discuss. We'll discuss the services in a separate session because we are starting here right now. Okay. Just give me some more time. Okay. So the question was the master. Why do we have a master and why do we have worker? I think someone has this question. Is it answered or again you want me to explain it to you?
So it is completed. I have
Yeah,
a clear
wonderful.
picture now.
Wonderful. So understand that in simple way. Master needed to manage the cluster, worker node, but worker is place where the application run. Now coming back to my discussion. See, cluster setup is done. What I wanted to tell you, my question was, what is a namespace? And for that to understand the namespace, we need to understand, okay, this is my cluster. And here powered by multiple worker, I don't want to talk about it. This can be 3 node, this can be 300 nodes where my applications is running. Application means this pod is running. So in reality, pod will be running in the worker. But when we look at it from outside, we say cluster. Are you understanding? No one will remember this node actually where the application is running. Everyone say, hey Rajesh, I'm running in the Kubernetes cluster. But if I ask you which node it's running, so you will respond, hey Rajesh, why you want to bother about it? Because today maybe it's running in the node 1, but tomorrow you want to automatically it will be running in the node 45. So you don't want to know that. Just the only thing which you should know is the cluster. Are you understanding? This node will change,
Yes,
may
yes,
change.
Rajesh.
Okay, so that's the reason I'm not talking about this node. Forget about this node worker anymore. Anyways, now talk about the cluster level. Okay, so far so clear. Can I move on further?
Yes, Rajesh.
Okay, by the way, I forgot his name who has given explanation. What was his name?
Rashish.
Ashish, yes. So Ashish, you will be the champion in your team. So any internal questions again, if arise in Kubernetes, so you can reach out to Ashish if I'm not available during after the session. Okay. So you can put it in the WhatsApp group also. Okay, because I felt he has a clear understanding about the architecture. Okay, so now let's get into the main question. What is a namespace? So namespace, basically, understand this way. I was explaining you the scenario actually. So this is the project 1. This is the project 2. So like that, in real time, one clusters will be shared by tens of project. For entire organization, there'll be one cluster. So let's say there's one organization called DevOps School, and they'll be having 15 project. So everyone use the same cluster actually. This cluster right now is powered by 3 worker in this image, but actually in reality maybe 300 workers also. Okay, so that is I don't care about it. Now next thing is the problem. The fighting will start, and this I would like you to focus on this fighting. See, when there is one cluster, one resources, why I say one resources, because in the clustering all the resources of CPU, RAM and hard disk, CPU, RAM and hard disk, CPU, RAM and hard disk combined, it that is a Kubernetes that work is doing. actually. So what happens? There is a two project. There is one cluster. This project has deployed the red pod, and green project has deployed the green pod. Now what happens? Think and tell me this answer, okay? Think and tell me. Let's say this pod has a container. Container comes from the image. Image has applications. So this application is having some bug. This bug. And the bug is like this: it start consuming lots of CPU, lots of RAM because of that bug. Open-ended bug is there. So tell me one thing. So green one pod has a bug. The moment you run that pod, it start consuming lots of CPU, lots of RAM, and so on. So tell me that it's consuming almost all the resources on the cluster. So tell me that whether the project red, will it get impacted from this behavior, this bug, or not?
Yeah, yes, of course.
Why?
Because internally, even it is linked up. Like when an application runs, even that is linked up to that, right?
Linked
It
up to
is
what?
like disturbing the hardware resources.
Wonderful. Yes.
Yeah.
See, theoretically, if you look at this architecture, this guy is having bug in the pod, but actually this is running in this machine, no? And this
Yes,
is running in this
that's what I'm.
machine, and this is running in this machine. So all the machines is getting impacted, and unfortunately, red is also running the pod in this machine, this machine, this machine. So now the red people are very red actually. These people are furious on the green, saying that how dare you deploy the pod without a testing, because of you guys we have a downtime, you guys are consuming lots of resources of the cluster, you are not ethically and process wise allowed to do that. So this is one incident. So what I'm trying to say here is, this might happen, this might not happen, but two team will fight for resources. Resources means team will say I need a more RAM, team 2 will say no, I need a more RAM, something like that. They will fight with each other resources. Correct now? Correct.
Yes,
Now
yes, yes.
second incident has happened next month, and that incident happened. So this green team, what they did, there is one notorious guy, just like in our group today we had a notorious guy, no, he just changed some changes and then this stopped working. So in this team there's one notorious guy, and he has a habit of trying something which is something he wants to do, something he wants to learn, and something like that. He is do something because everyone has access to this guy. By mistake, remove the pod of red by mistake. It's like he was not intentionally doing. Now red is furious. I mean, again, green guys is there. Sorry, let's say this guys, red guys is the problem. Okay, so red guys did some changes to the green guy. Now green guys teams are furious, saying, how dare you touch my pod? Who allowed you to do this? Because of you we have a client escalations, our application is downtime, SLA got reduced, SLO got problem, we have to pay for this much because of this downtime. Correct? No, this incident may happen, right?
Yes.
So what I'm trying to say, when you have a multiple team working for the multiple project is working for the same cluster, in the same cluster, fight will occur. We call it infighting issues. Fight for the resources like RAM and CPU, fight for the access, unauthorized issues may pop up. So now the question is how to deal with it, how the Kubernetes will deal with it. So Kubernetes has introduced one API resources, and which is called namespace. What we call it? Namespace. And mind it, look at the drawing. I am doing the horizontal drawing. So they say, hey, listen, don't fight. Don't fight. You do one thing, we'll introduce one namespace, and namespace in that. So that means you deploy the pod in your namespace. And what I will do, I will set the namespace level one limit. That means no matter how many pods you run, let's say this is the 5 GB, 5 GB, 5 GB. So total cluster is 15 GB. So I'll say no matter how many pod you run, you can maximum consume 7 GB. And this namespace people will maximum consume 5 GB, 4 GB. So this is the limit I set at the namespace level. So first I will create this namespace and then I will deploy the pod inside a namespace. Again, mind it, it's not a physical separation. We are not dividing the cluster physical way. It's a logical division. So still this guy will be, the pod will be running in this machine only. This pod will be running in this machine only. But Kubernetes control how much resources you can use overall. You can ask for this node because ultimately resources are here, right? So you cannot ask more than what is set at level of namespace. So now the fighting is over for the resources. If there is a bugs, this guy is consuming, but maximum you can consume 4 GB, no? Still you have a remaining 7 GB for the other projects or other projects for the backup. Are you understanding this concept, all of you?
Yes, yes.
Yeah,
So now
Raj.
how do we solve the other problem? So what Kubernetes says, hey, listen, don't give a permission to the cluster wide. Don't give. It's a wrong practice. Yeah, super admin will have a access, but what you do, this team who's working for the project A only give the access to this cluster. Different level of clusters access you can give it. That sorry, namespace. Sorry, namespace. So now, no matter what you do, you cannot modify this namespace spots because you have access only to the your own namespaces. So this kind of issues can be addressed using a namespace. What is a namespace then? Namespace is a logical division of cluster. Logical, not a physical. It's not like this is your land, this is my land, this is my server, this is your server. No, you all are. Both the team is still using the same server. But logically, Kubernetes has a control over your uses and access. That's called cluster management capability by the Kubernetes. Are you understanding?
Yeah, yeah, Rajesh.
Yeah. So the question is, this is the namespace. So what we have, so this you can divide, create a, how do you work with it? So here kubectl get ns. So see here, these are the ns means namespace already there. Why? So then they said, Kubernetes said, hey, we have a namespace concept, so we can divide the resources and access and all stuff like that based on the namespace. So let's do one thing. I'm also running lots of pod, and for our pod, system pod, for system pod, let me have this pod. So I will create all of my pod in the namespace kube system. Wonderful, no problem. They have created their own namespace and they have deployed all of their application. This will manage your cluster. I repeat, this pod only manage their entire cluster. And they have deployed in the namespace which is called kube system. Then you will say, Rajesh, okay, I see there is one more namespace is there which is default. I have not created, it's coming default. So what is that for? So this is for the worker administrator maintenance work. So if you want to do the maintenance work, for that you have to run this one, what is it, a pod, so you can keep the pod running over there. Common pod you can run in this different project, and this is a default. So those who's having a no namespace will be a part of the default namespace. So now the question is, how can we create a namespace? Very simple. Create ns dev qa. I created two namespace. Sorry, I created a namespace. So all of you understood the namespace concept?
Yeah, but one small issue, Rajesh. Like,
Yeah.
can we manually set the space for it, or Kubernetes defaultly takes the space or the requirements which are required?
So typically admin, what they'll do, each project they'll create one namespace and assign access only to their own namespace, and you will work in your namespace actually.
Is there any format like in one cluster there are only two namespaces, anything like that, or it can be any number of
Any number of
name?
namespace, because remember that
Oh,
cluster has no limitation of namespace, but resources are limited. No, only 3 nodes you
yeah,
have right now.
that's what I'm asking.
Yeah, so resources are limited. Cluster these objects, as long as your resources, pod is consuming cpu and ram, namespace is not consuming cpu and ram. Pod run container ask for cpu and ram.
Yes. Yeah.
So like that.
Okay, Rajesh. Thank you.
So here I
Yeah,
created.
Rajesh, how can I get to know that which is my cluster here?
I
On
repeat.
which cluster I am, and on which
Ha
cluster I am working actually. I am
ha.
creating some of the namespaces and all. So I just want to know where I am in which cluster.
Yeah, very good question. So for that, I can give you the answer is lies in this file, and I think you know that file. Let me remind you. Did I not copy it? I think I did not copy. No problem. So that config file, remember? More answer is hidden in this. So which is your cluster? This is it. What is the name of the cluster? Kubernetes. But this probably you will not understand too much, so no need to worry about it. Simply you can say kubectl config view.
Only okay.
This is your API
So
server.
and only one cluster can run in the machine, or more than one clusters can be run.
Look at this image. I'll keep it open. Look at that. So one
Okay.
cluster means what? Cluster means what? Why we have a cluster concept? See, one cluster or 10 clusters, whether one cluster you can run in the two cluster. See, cluster we create so we can manage the hardware, VMs, and we can deploy the pods. So one cluster means one resources. Means if you have a 5 node and you created one cluster with a 2 node and another cluster with a 3 node, so you'll have a 2 cluster. But if you have one cluster and 5 worker node you add it will become one cluster. It's up to you theoretical. Okay, one more thing. Whenever you think, uh, put yourself in the operations bucket. Means you are a guy who's managing the thousands of servers, and that you want to manage it where you want to deploy your applications. Put it in this way. Got it?
Got it.
So you don't want to share the two hardware resources for three cluster or two cluster. It should be for one cluster. Because cluster itself can be shared with a multiple team. No, just now we discussed. Correct now?
Yes.
Team 1 and team 2 using namespace.
Yeah. Is there any command? You just went to the config file. That's it. So by doing the config, by looking into the configuration file only, we can understand that. That is
Yeah.
name of the IP and followed by the port in which it is running, right?
This is API server in short. API server.
Yeah.
This is API
And
server.
the API server is the server itself. This
That
the
only is
machine
doing
itself.
every management, right?
Yeah. Okay. And what is the Kubernetes cluster? Okay, got it.
Okay, so this is the stuff. So I was discussing about the pod. Okay. So, sorry. Namespace. So guys, namespace you understood all of you, right?
Yeah, Rajesh. Done.
Okay. Now guys, please focus on my screen. Focus on my screen. You just look at this table, guys. So here, if you see left side name, which is the resources, after that short names, and after that version. Okay, version of that particular resources. Now here you have a namespace true and false. So what does that mean? Anyone would like to tell me if you know, because I'm
True
little.
in the
If it
state, it
is
is. Oh, continue.
One by one. Yeah, tell me.
True means something like it is present, and
if it if it is related, the resource is related to namespace, it is true. If it is not related to namespace, it is false.
Yeah, good. Any other inputs on top of it?
If the namespace or the particular cluster is working inside the nodes or whatever it is, then it is showing it's true. And if it is not working or it is kept silent, then it is false.
Okay, I'll ask you two questions. Okay, look at this image which we have been discussing from last 15 minutes. Okay, tell me, the pod is inside a namespace or cluster wide? Tell me.
A namespace.
Yeah, see that
Inside the
pod.
namespace.
See that pod. Pod is inside a namespace now. See the pod.
Yes.
See the namespace. Now I'll show you the real one also. So I showed you multiple one. See that. Look at it very carefully. All pods I am displaying with you. Okay. Look at this. These are the pod 1, 2, 3, blah blah blah. Now you see that. This
Yes,
belongs to the
Rajesh.
namespace, correct? So
Yeah.
actually, pod belong to the namespace, correct? Now tell me, this is a worker. This is belong to namespace or entire cluster? This worker.
Entire cluster.
Entire cluster. So here, let's put it in this way. There are resources which you can create only in the namespace. So the resources is namespace true. Let me show you the command one more time. So here you see why is here, if you look at this pod, why is true? Because the pod can be created only inside the namespace. But let's look at the node. Where is that? Here it is. So look at this false. Why is false? Because because his node is at the cluster level. That's the reason namespace false. So here you have a 57 resources. Out of his some resources you can create at the namespace, but some resources you can create at the entire cluster level. That means that resources which is available at the cluster level, everyone can use it. But the resources which is available at the namespace level, only those who's a part of that namespace can use it. Make sense?
Yeah.
So that's the reason we have a namespace true and false, because of, so there are some resources can be created at the cluster level for an entire cluster, such as nodes, some resources which is at the pod, namespace level, which is a pod down. So every resources, it can be true or false as per the scope of it. Make sense?
Yes, clear, Rajesh.
Yes. Okay, so now after that, guys, I'll give you one magic formula. Okay, magic formula. Why I'm giving you magic formula? Because I'm a microservices developer also. So I feel explaining this one is easy compared to the giving you the commands blind way. So guys, here understand this. API server, you know what? API server, this is a server, and here you have a how many APIs? Let me show you how many APIs you have. You have 72 APIs. So guys, what do you do with the API? Each API, what can you do? Tell me. Each API, you might have worked with the Facebook API, Twitter API, LinkedIn API, Amazon API, Flipkart API, or you know that API, right? So what do you do with the API?
Some are used
Like,
for commenting, liking.
Anything
You will
else?
get the information.
Each
Get
each API has its own functionality by issuing the request and response in the format.
Good,
yeah,
good. So each API is equal to one function, okay?
like
Function,
sending the request in HTTP and receiving in a JSON format, I think. Yeah, that is only also.
that is also. So here I'll tell you that each API V is equal to one function, okay? And each API, once you ask a developer, hey guys, tell me how do you develop this API? So he will say simply, hey, I did not do anything great. I just created one function which is called create, and I created another function which is called read, and again edit, update, and delete. So this function developer has created. This is done by developer of the microservices developer. So that means if you are developing a function, no, you should have these four functions into it. So create, read, update, delete. That we call it a CRUD. Have you heard about it?
Yeah.
Yeah. So this is the
Yes.
something which do. Now for the end user perspective, what they will do, end user perspective. So how would they call this function? So they will call through what? So put get
Post.
post and last one delete. This is called HTML verb, right? HTTP verb, sorry. If you put it in Google, HTTP verb. Have you done the software development?
No, Rajesh.
You should try actually. At least one simple application develop. No, don't get scared from the programming and all. Take one Python program, Python project, and read through that. They will see that 4 functions only, 1 microservices. Okay, so try this one. You remember that DevOps allows you to learn everything, but not allow you to scared, because DevOps says, hey, don't learn everything. Don't deep dive into everything, but learn everything. Something like, so you programming just 5 lines of program here, 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 and just insert name and age. So you created a name and age, read the name and age, update the name and age, and delete the name and age. Now this is something we do that is just like within a 2 to 3 hours you will do that with the help of Google. After that, you make it available. These are the URL. So URL, they will call this URL and this pass this verb, put, get, post, and delete. That is how you do that. See here, this is the URL. See here. So get inventory, post order, get order ID, delete order ID. Correct now? All of you are understanding, right?
Yeah, Rajesh.
Okay,
Yes,
so
Raj.
next thing you must be wondering why I'm talking about all this thing, guys. This 72 APIs also you have to do the CRUD only. Each API, namespace is API, pod is API, this is API, that is API. 72 API which I'm showing you, these are the APIs actually. So you have just need to know what exactly these APIs are for, and what you need to do is you need to do the CRUD. That's all. So can we do the CRUD? So I'll teach you the pattern for every 72 APIs. So create, read, update, delete. How do we create? Through command line. How do you update, create using YAML file also? Both the way, JSON also you can use that. Okay, so here also command, YAML, all this thing, you know, sorry. So command, YAML, command, YAML. So these all things we can do that, each one of every action. So now the question is, can we find out the command for it? So guys, look at my screen, all of you, and we will find ourselves only together. I'm not going to teach you. So tell me one thing, where is the command for create? Tell me.
The first one, beginner, below the
Basic.
beginner.
Wonderful.
Create.
See, I'm not finding, you only finding it. And YAML, I'll just teach you. Create -f YAML file. That means kubectl create -f kubectl create command. Kubectl you have to add it in every command. Can you tell me where is it read command?
Get.
See, you are finding describe. There's one command I'm adding from myself. Okay, so here describe, you see somewhere here, you see here. Okay, so YAML what? Get -f YAML file. Okay, update. Can you please tell me how can we update command for it?
Set.
Apply.
Edit also, no? Edit is there also. Correct now?
Yeah.
So edit and command and YAML file. Then for that we have apply -f YAML file. Okay. So see, one more thing. It's not only for the namespace. It's for the entire 72 resources, by the way. Okay. This pattern I'm teaching you for everything. Okay. So now what is the delete? Can you tell me?
Delete.
Here. So now you got to know how can you work with each API service in one go only. So you don't have to ask anyone how can I do this, how can I do that. You just know what is a pod, what is namespace, what is a replication controller, what is service, what is this, what is that. You apply this logic to every API resources, not only in the Kubernetes, outside of the world also, because I am telling you from the coding perspective. Getting my points?
Yeah.
Okay, so now let's start doing with namespace. Okay, can I do that? So guys, look at my screen, all of you. I'm doing in the context. So how do I get the namespace? kubectl get ns. How do I edit the namespace? How do I create the namespace? Create ns Raju. See here, get Raju. How do I edit this? So edit Raju, create no edit ns Raju. Here what I want to add it. So right now I'm not adding it because I don't have a knowledge right now. So if I don't have a knowledge, then you always stick to your mind, change the labels. And it's YAML, no tab, only space. And here what is the environment? This you are running, let's say my devo environment, something like that. You just add it, save it. Can I see this? Get ns. Can I describe this and see the label got added or not? So Raju, right? Raju namespace. Spelling mistake, guys. Raju namespace. See here, this labels got added. Now, can I delete that? See here the fun of it, and see that get ns, get ns, get ns. It's not there. Gone. Gone. Understood this? How do you use the CRUD operation and the magic formula which I said with every APIs which you can apply? Are you understanding, all of you?
Yes, Rajesh.
Yeah. So guys, yeah. So this is the stuff. Go with the concept. Each and every output. Don't run this command. I have run already. Okay. And try these all commands. And this. And remember this algorithm. And do it. And after that, we'll go ahead and wrap up the session. And tomorrow I'm going to teach you pod, replication controller, and deployment, something like that. Okay. So I need to be slow because you guys will understand the concept. If I try to hurry, probably you guys will get confused. I just felt it. The problem is only timeline. When you have a time, no, then you explain in a relaxed way. But that is a challenge. Any questions anyone have? Any question? Okay. Before
If
going for
you don't mind, Rajesh, can I get your credentials for this, what you call it, your Ubuntu master node, so that we
I
can
gave
work?
it. No, I gave it to you. Did you
Yeah,
miss
you
the
gave it,
session?
but is it okay if we work in it?
Yes, so it will be accessible up to the 2 o'clock. After that, it will be shut down. I mean, shutdown is stop. Okay, so this will be available during the session, maybe a little bit of 1 hour extra, but after the session will be stopped. If you want me to run longer duration, then talk to Raju or Prashad or someone, and if he'll approve me, I will run it more also. No
Yeah,
problem.
sure. Just to practice this, so whatever you
No,
suggest.
no, no. Uh, Funny, we can
Yeah, sir.
install that in our lab, right? We have the lab servers and we can install it
Yeah.
because, yeah, he's running the AWS, instance. So that is the reason, I think. Yeah,
Okay.
and one more thing, Rajesh.
Yeah.
Rajesh, I just pinged you early in the morning today for, AWS lab. Did you, I mean, just wanted to know, like, our company subscribed for that AWS lab session from you?
Okay, I'll tell you this one. Can we discuss offline, because there's
Yeah,
some
yeah, yeah.
instruction come from the Prashad. So after this session, you can call me. Okay.
Yeah, yeah, sure.